Welcome to the Basics of Trigonometry. Let's begin with the basics of right triangles as a refresher. All of the interior angles of triangles add up to 180 degrees, as denoted by angles A, angle B, and angle C. Lines 1 and 2, also known as the legs of a right triangle, form a right angle at angle B, which is 90 degrees, as they act perpendicular to one another. Line 3 is known as the hypotenuse, or the longest leg in the right triangle that doesn't form a 90-degree angle with any other side, or leg. Angles A and angle C in this right triangle don't individually equal 90 degrees, however they add up to 90 degrees. Do you remember the Pythagorean Theorem and how to use it? The Pythagorean Theorem states that a squared plus b squared equals c squared. So if a equals 3 and b equals 4, then 3 squared plus 4 squared will equal c squared. Remember, c is unknown, and 3 squared plus 4 squared will translate to 9 plus 16. And when we add that, we'll get 25 is equal to c squared. So to isolate c squared, or to isolate c, we would just take the square root of c squared and 25, and we'll get c equals 5. So what is trigonometry? Trigonometry is the study of ratios and relationships between various side lengths and angles of a triangle, and can be applied to almost any real-world scenario, such as finding elevation between two physical mediums or finding directional flow and magnitude of electrical charge. There are three main trigonometric functions you need to know in order to calculate various proportions and ratios within a given right triangle. They are sine, cosine, and tangent. They follow a particular mnemonic that you need to remember in order to perform various trigonometric functions, known as SOH-CAH-TOA. I'll repeat that one more time, SOH-CAH-TOA. So in the SOH part of SOH-CAH-TOA, sine equals opposite over hypotenuse, and in the CAH part of SOH-CAH-TOA, cosine equals adjacent over hypotenuse, and in the TOA part of SOH-CAH-TOA, tangent equals opposite over adjacent. So how does SOH-CAH-TOA look visually? So we'll do a few practice problems to understand this. Note one thing. The theta symbol in the triangle is always used to represent an angle measure, so it's shown here by angle ACB. So in this scenario, given theta, find its sine ratio. Remember, sine equals opposite over hypotenuse, so to find the opposite side length, look directly at the side that is opposite the theta, which would be line AB, which has a measure of 4. And then to find the hypotenuse side length, always remember the hypotenuse is the longest leg in the triangle that doesn't form a 90-degree angle with any other line, and this doesn't ever change. Thus, the hypotenuse side length would be line AC, which has a measure of 5. Thus, the sine ratio of theta in this scenario would be 4 over 5, taking into account that the opposite side length was 4 and the hypotenuse side length was 5, when we're going by SO in the SOH-CAH-TOA part. So in this case, given theta, find its cosine ratio. Remember, cosine equals adjacent over hypotenuse. To find the adjacent side length, look directly at the side length that is neighboring theta. Once again, this is never the hypotenuse, which would be line CB, or shown here. And it has a measure of 3. And to find the hypotenuse side length, always remember the hypotenuse is the longest leg in the triangle that doesn't form a 90-degree angle with any other line, like we said before. This doesn't ever change. Thus, the hypotenuse side length would be line AC, which has a measure of 5. Thus, the cosine ratio of theta in this scenario would be 3 over 5, taking into account that the adjacent side length was 3 and the hypotenuse side length was 5, in the CAH part of SOH-CAH-TOA. Given theta, find its tangent ratio. Remember, tangent equals opposite over adjacent, so to find the opposite side length, look directly at the side length that is opposite the theta, which would be line AB, as shown here, which has a measure of 4. And to find the adjacent side length, look directly at the side length that is neighboring theta. Once again, this is never the hypotenuse, so in this case, it would be line CB, which has a measure of 3. Thus, the tangent ratio of theta in this scenario would be 4 over 3, taking into account that the opposite side length was 4 and the adjacent side length was 3. So, how does SOH-CAH-TOA work when we're given the hypotenuse and the angle measure but not the leg? First, we must evaluate what trigonometric function we're going to use in order to find the value of x. So in this case, we're given that angle BAC equals 72 degrees, shown here, and then line AC equals 5, which is the hypotenuse, and line CB we don't know yet. Based off our knowledge of SOH-CAH-TOA and given the information about the triangle above, we can notice a pattern that opposite to angle BAC is line CB, and line AC is the hypotenuse, which is given to us and has a measure of 5. Thus, we can conclude that we need to use the sine function to find x as the opposite hypotenuse side lengths fall into the SO part of SOH-CAH-TOA. So in SO, sine equals opposite over hypotenuse, as denoted by S, O, and H. So let's start out by setting up an equation. So we would set up as sine of 72 degrees equals x over 5. Then to isolate x, we would multiply by 5 simply. And when we do, we'll get x equals sine of 72 degrees times 5. And when we evaluate that in our calculators, we'll get x approximately equals 4.76 when we round to the hundredths place. So how does SOH-CAH-TOA work when we're given one leg in the angle measure but not the hypotenuse? First, we must evaluate what trigonometric function we're going to use in order to find the value of x. So in this case, angle BAC equals 28 degrees, line AC we don't know yet, and line AB equals 7. Based on our knowledge of SOH-CAH-TOA and given the information about the triangle above, we can notice a pattern that adjacent to angle BAC is line AB, as shown here. And we're not given the hypotenuse side length, which is right here. It's line AC denoted by x. Thus, we can conclude that we need to use the cosine function to find x as the adjacent and hypotenuse side lengths fall into the CAH part of SOH-CAH-TOA, in which cosine equals adjacent over hypotenuse, as denoted by C, A, and H. So let's start by setting up an equation. So we'll set it up as cosine of 28 degrees equals 7 over x. And when we multiply by x, we'll get cosine of 28 degrees times x equals 7. And then to isolate x, we would have to divide by cosine of 28 degrees. So we'll get x equals 7 over cosine of 28 degrees. And when we evaluate that in our calculator, we'll get x approximately equals 7.93 when we round once again to the 100th place. So how does SOH-CAH-TOA work when we're given the legs of a triangle but not the angle measure? First, once again, we must evaluate what trigonometric function we're going to use in order to find the value of x. So in this case, angle ABC we're not given, it's denoted by x degrees. Line AC is 4 and line AB is 7. Based off our knowledge of SOH-CAH-TOA and given the information about the triangle above, we can notice a pattern that opposite to angle ABC is line AC, shown here, which has a measure of 4, and adjacent to it is line AB, which has a measure of 7. Thus, we can conclude that we need to use a tangent function to find x degrees, as the opposite and adjacent side lengths fall into the TOA part of SOH-CAH-TOA, in which tangent equals opposite over adjacent, as denoted by T, O, and A. So let's start by setting up an equation. So we'll set up as tangent of x degrees equals 4 over 7. So first we'll have to divide by the tangent function. However, whenever we have to divide by a trigonometric function, we always have to take its inverse, as denoted by the -1 right here. So we'll have x equals the inverse tangent function of 4 over 7. And when we plug that into our calculators, we'll get x approximately equals 29.74 degrees when we round once again to the 100th place. So this is a word problem, a real-life scenario that you might have to deal with in your life. So anyway, a robotics team, part of Lake Nona High School, was requested by judges at a local Lockheed Martin competition to calculate the angle of depression needed to lower the robot's arm to have the electromagnet attached to it successfully attract other magnetic objects. So let's calculate the angle of depression to help out the Lake Nona High School robotics team. So first of all, what is angle of depression? We have not covered that, but it means an angle that is produced when measuring below a surface or horizontal axis. Okay, so from the problem, it says that the mechanism extends about 18 inches horizontally, shown here, which is line CB, and it needs to descend by 8.5 inches in order to attract the objects. So that's line AB, as shown here. So based off of the given lengths and their relative positions in the triangle, we can see that we need to use the tangent function, as the diagram shows a length of line AB opposite to x degrees, and a length of line CB, which has a measure of 18, and that's adjacent to x, so shown here, so opposite and adjacent. So thus we'll have to set up the equation as tangent of x equals 8.5 over 18, as 18 is 8.5 is opposite and 18 is adjacent. So then once again, whenever we have to divide by trigonometric function, we must take its inverse, so we'll get the inverse tangent function of 8.5 over 18, and when we plug that into our calculator, we'll get x approximately equals 25.28 degrees. So what that means is that the mechanism must descend by 25.28 degrees approximately in order to have the electromagnet shown here attract the other magnetic object. Thanks so much for watching, everyone. I hope you guys enjoyed.